Next unit is on systems of equations. So basically, a system of equation is a set of more than one equation with the same variables. Point of intersection of two graph equations is the solution of the system of equations. So the ordered pair is going to account for like the variables in it. So one variable on these equations. You know, most of the equations we've been doing, we solve for a variable. That's going to be the different part here. So here's what these look like. There are a couple different ways we can solve these. Two of the ways we're going to get to in the next few days. Two of the ways we're going to do today. Okay. One way is by graphing them. So if you graph each of these equations, I'll start with this one because it's easier. Y equals 5. Y equals 5. Right there, horizontal line through the 5. Our other equation, y equals negative 1/2 x plus 3. Graph it the same. Y-intercept is at 3. We got negative half, so we go down 1 over 2, down 1 over 2. Go the opposite the other way. All right, so there would be my two lines. Not super difficult, right? What we're looking for is the point where they cross. So the ordered pair where they cross, my x value is negative 4. Y value is 5. This method is pretty simple if you have calculator active and you're using that online calculator for like a test. All right, put in the two equations, see where they cross. The other way we can do this is by solving. So the other way, we can make them equal to each other. See how both of these are y equals? All we have to do then is we can make negative 1/2 x plus 3, set it equal to 5. And I solve. So I subtract 3 from each side. I got negative 1/2 x equals 2. Divide by negative 1/2. Why divide by a fraction? I do keep change flip. So I'd have 2 divided by negative half. That becomes 2 times negative 2 over 1. So when we multiply, we got x equals negative 4. That's what we got where it crossed, right? So we still need the y value, right? This one's kind of easy. Kind of tells you right there, doesn't it? So we know what y equals already from that one. If we did not, what you do is you take the x value and you got to bring it and plug it into one of the equations. All right, so next one we do, you'll see it kind of a little bit better how that works. But you do negative 1/2 times negative 4 plus 3. Negative half times negative 4 makes positive 2. 2 plus 3 makes 5. All right, everybody kind of follow? Any questions so far? Graphing them, like I said, easy with the calculator, not always realistic if you have bigger numbers or things like that. Solving it works with certain equations. We'll get the other two methods later. So let's look at this one. We got y equals 1/3 x minus 2 and y equals negative x plus 2. And where they intersect, I'm not going to do that one. All right, I'm just going to set them equal to each other and solve. So I've got x minus 2 equals negative. Everybody good there? All right, so we will move the variables. All right, we would distribute combined like terms if we had it. We don't have that. So we're moving the variables. We will move the lower variable. The lower one's the negative. So we add an x to each side. Remember, when it's just x, that's like a 1x, right? So we would have 1 and 1/3. I'm going to make that improper, though. So 4/3 x. Doing math later on in the equation, an improper fraction is going to be easier to work with than a mixed number, okay? So that's why I did it that way. Minus 2 equals 2 is all that's left on the right side. Do opposite. So we got 4/3 x equals 4. We divide by our fraction. Again, when we divide, we got 4 divided by 4/3. We do keep, change, flip. So 4 times 3/4. That's 12 over 4. What's 12 over 4? 3. And what that is that is my x value. That's what we were solving for, right? When we get it down to the end, we would have x equals 3. We need to get the y value. You just have to pick one of those. You should, if you do the math correctly, get the same thing for both. Neither of these are exactly ideal. One of them has a fraction, right? One of them has a negative number. It doesn't make a difference which one you pick. You should get the same thing. So I'll do both of them. So if I take this one here, I got 1/3, plug in my 3 for x, and minus 2. 1/3 of 3. So that's like 3 divided by 3. That's 1. 1 minus 2 makes negative 1. Everybody follow on that? If I use the other one, put 3 in for x, that's negative 3 plus 2. Signs are different. We subtract. Look, still gets negative 1, right? So that's the answer. 3, negative 1. Do you have to plug it into both equations? No. But that's the easy way to check your answer. If you did it correctly, plugging it into both equations, you should get the same number each time. All right, so if we look at these, we got 2 companies there that make t-shirts. First thing we need an equation for each one. All right, so if I take company A, make company A purple, what's the y-intercept for company A? Oh, yeah, 0. Company A, y-intercept, 0. All right, so we're going to have y equals something x plus 0. We don't need the plus 0, though, right? So now we just got to find the slope. So we use a point on the graph. We use that point right there. What are our words for slope? Rise over run. So my rise, how much is my rise? 3. We We got to pay attention to the labels, not the number of squares. So rise is 3, run is how many? So I got 3 over 1, which is just 3. So we got y equals 3x. Everybody good with company A? Company B then. We'll do that one green. What's the y-intercept for company B? 6. We got it right there. So we're going to have y equals something plus 6. All right, so now we got to find the slope. If we use the next point, that'd be right there. So my rise is how many? 3. Again, got to use the labels. And my run is how many? 3. So we got 3 over 3. That's 1. If you really want, you could put 1x. You don't need to put 1x. Equations. Everybody good with how I got the equations? All right, B here says how many shirts would be needed or would need to be ordered for the cost to be the same for either company? 3. Who's not sure where we got 3 from? So we got 3 shirts. And then it says, what would the total cost be? So what would the total cost be? None. Yeah. 3 shirts, $9. That's then, if you have the graph, just paying attention to what the labels say. The x-axis was the number of shirts, so the x value is how many shirts. The y-axis was the total cost, so that's the money. All right, Justin needs to order 5 shirts. We need to know which one's cheaper. Look, all this does, Justin needs 5 shirts. 5 shirts is right here. If I follow it up, y'all, which one's lower? Company B or company A? B. Everybody see that? All you're doing there, looking for that. Any questions there? All right, y'all try this one. This time we got some siblings saving money. Who thinks they have an equation for Tate? No? Not 25.
Y equals 3 halves x plus 10.
No. That'll work. I'm going to make a change. Since it's money, you would probably see a decimal on this graph. So we'd have y equals, if we use the points right there, our rise is 15, our run is 2. 15 divided by 2 will give us $7.50. Y-intercept, 10. So there's the next equation. All right, rise, overrun, get our slope. For Tabitha, things with Tabitha's. Y equals, again, 5 over 2 makes it easier to graph. That's our rise and our run. She had 20. We go up to 25 over 2. Since it's the decimal. And her y. All right. Everybody good on those? That's it. If you kept them as fractions, if you kept it as 15 over 2 or 5 over 2, that's fine. That's easier to work on. So B says, how many weeks will the siblings have the same amount, and what will that amount be? 2 weeks, $25. All that we're looking for right there is the point where they are crossing, okay? They cross right there. Our X value is the number of weeks, that was 2. Y value is the amount in their account, that's 25. All right, after 5 weeks, who has more money? Tate. I don't know why they picked 5 again, but they did. So we just go up from 5. Tate's line is higher. It has more money. Any questions? All right, so flip that sheet over. When you graph these, or if you graph these, there are 3 possible things that can happen. The lines can cross, the lines can be parallel, or you can end up with 2 lines on top of each other. Okay? If the lines cross, that is what you will see most of the time for these kind of problems. That's one solution. Now it says one solution, but that's still like the ordered pair, the X and the Y value, okay? So you're still getting like the 2 variables. What we have, the lines have different slopes, and obviously if it's one solution, they cross at one point, or intersect at one point. All right, if the lines don't cross at all, what do you think that would be? No solution. So if you got 2 parallel lines, what do we know about parallel slopes? Same, so the lines have the same slopes and different y-intercepts. That means they don't intersect. That means it's going to be no solution. All right, so how many solutions does the last one have? Infinite. If we got 2 lines and they're like on top of each other, they're touching everywhere. That means every single possible point is a solution. And then obviously they have the same slopes, the same y-intercept. So everything's the same there. Kind of like when we're solving equations, right? All right, go ahead and find the point where these 2 intersect. You can either graph them or you can solve them. Either way, but we need an X value and a Y value. All right, everything they got it? Adrian?
4x 3y.
Yeah, the 0.43, 4 for your x value, or x equals 4, and your y value would be 3. Just I'm curious. Anybody graph them? One of y'all? So, if you graph them, that second line, we got y-intercept is 7, slope of -1, looks like that. The first line, y-intercept's 1, slope's a half. Line's looking kind of like that. You can see where they intersect. Otherwise, what you need to do is you need to set them equal to each other. So we got 1/2 x plus 1 equals -x plus 7. Not always, but for the most part with these, you will see one negative slope and one positive slope. It makes it easier for them to intersect that way usually. Like I said, occasionally you'll see it with both positives. So we move the lowest one, that's the negative. Just like before, when I add that, that's going to be 1/2. I'm going to make it improper. So that'd be 3/2x plus 1 equals 7. I go -1. So I got 3/2x equals 6. Now, I can divide by the fraction and do keep, change, flip. I can also do that in pieces, okay? So I'm doing the opposite. What I have right there is 3 times the x, and it's divided by the 2. So the opposite of multiplying by 3 would be dividing by 3. 6 divided by 3 is 2. The opposite of dividing by that 2 there on the left side is multiplying. 2 times 2, we got x equals 4. Then we just have to plug it back in for y. 1/2 times 4 plus 1. 1/2 of 4 is 2. 2 plus 1 gives us 3. Or -4 plus 7, sounds different. We subtract. It's not a big number. That gives us y equals 3. So either way, getting the same thing. Any questions on that one? All right, try the next one. This is one where the two slopes do end up as positive. All right, everything I got? Ryder?
No solution?
No. No solution would have to have the same slopes. And these do not have the same slope. -2, -3 is correct. All right, so if we set them equal to each other, which one's lower, 3 or 1/2? 1/2. So, we're going to subtract 1/2 x from each side. 3/2 minus 1/2 would be 2/2, or that'd just be 1. So we'd have x equals, those canceled, -2. Well, that tells us what x is. So there's our x value. If we plug it in, to me, this one would be the easiest one. We take the 1/2 times -2, and we're going to subtract 2. 1/2 of -2 is -1. -1 minus 2. Signs are the same. So we would add, keep the sign, that makes -3. Questions on that? And y'all graph it? So if you graphed it, for the first one here, your y-intercept is 0. We go up 3 over 2, up 3 over 2. If we go the other way, it's down 3 over 2. And connect the dots with a at least kind of straight line. For this one, y-intercept was -2. Slope is 1/2. So that goes up 1 over 2. Going the other way. Again, if my lines were a little bit straighter, that'd be a little easier to see where they intersect, but I did put dots. There's a dot right there at -2, -3. Okay? The dots are more helpful than the actual lines themselves.